Okay, I think what we can do for some additional practice is look at the other homework that I posted, the one that's taken from another book, and I have you do the questions that were circled, but that doesn't mean that those are the only questions there that might be useful for our purposes. And so that's the one that's basically this sheet. And you don't actually have to see the sheet to do this because I'm going to write the questions as we come to them. There are several questions here that we can look at that could give us some practice in things like algebra and unit conversions and that kind of thing. Number 2 is one of them. It says a human hair has a thickness of about 85 microns or micrometers or micrometers, however you want to say it. And they wanted you to convert that to meters and millimeters. Okay, well, all you have to do is look up the meaning of micro and find out that micro means 10 to the minus 6. So 85 micrometers, and if you want to go to meters, there's 10 to the minus 6 meters for every 1 micrometer. Okay, so this ends up being 85 times 10 to the minus 6. You notice micrometers cancel. Meters. This is, I did this in my head, which is why this is not proper scientific notation. So if we move the decimal point to make it proper scientific notation, we get 8.5 times 10, and moving the decimal point made the first part of the number smaller, so we have to make the exponent bigger. It's 8.5 times 10 to the minus 5 meters. And we can then take that and change that to millimeters. Because 1 millimeter is 10 to the minus 3 or 0.001 meters. And so if you take 8.5 times 10 to the minus 5 and divide it by 0.001, you get 0.085. Or 8.5 times 10 to the minus 2 millimeters. All right, so far so good, hopefully. Number 4, it's about an IBM computer. And a computer supposedly does 136.8 tera calculations per second. And the question is, how many calculations can it do in a nanosecond? Okay, well, we have 136.8 tera calculations. I'm going to call that capital T, lowercase c, for every 1 second. And the unit we want to convert is on the bottom. So we want seconds on the top of the conversion factor and nanoseconds on the bottom. And there is 1 nanosecond for every 10 to the minus 9 seconds. So seconds will cancel out, and we get tera calculations per nanosecond. So let's see, 136.8, right? Times 10 to the minus 9. To put that into proper scientific notation, that's 1.368 times 10 to the minus, never mind. 136.8 times. One, two, three, four, 5, 6, 7. Okay, so this is kind of an awkward way to report it. So we could replace tera with its metric prefix meaning. Tera itself means 10 to the 12 calculations per nanosecond. And so this might make the number a little more reasonable. Okay, yeah, 100,000. Okay. Okay, so 136,800 calculations per nanosecond is what we end up with. Okay, so the next several are about dimensional analysis, and it's an aspect of dimensional analysis that we don't really care that much about in this class. So we're going to skip over a few problems and come to 14. The speed of light is 2.9979 times 10 to the 8 meters per second. What is the speed of light to 3 significant figures? Okay, so that means we can take the 2 and the 9 and the 9, and then we have to drop everything from the 7 on. 7 is greater than 5, and that means that the number before it has to go up by 1 when you drop it. But that's 9, so that goes up to 10. The number before it goes up by 1, but that's 9, that goes up to 10. And the number before that has to go up to 1. So 2.9979 to 3 significant figures is actually 3.00. Okay, that's a hard one because you've got all these 9s and things in it. But you basically remember that when you're dropping some numbers, only look at the first number that's being dropped, and that tells you whether the last number being kept has to go up or not. And if that number has to go up by 1 and it's a 9, then it becomes a 0 and you carry the 1. Okay, 16. You're on a fishing trip and you catch a 2.77 pound bass, a 14.3 pound rock cod, and 13.43 pounds salmon. And what they're saying, what they want is the total weight of your catch. And the implication here, though, is that you're going to be following the rules for significant figures. And remember, when adding and subtracting, you go with the smallest number of decimal places. Okay, so 2.77 has 2 decimal places, 14.3 only has 1, 13.43 also has 2. So what we're going to do is add these numbers together and see what we get, and then cut it down to 1 decimal place. All right, so 2.77 plus 14.3 plus 13.43 gives us 30.5. It comes out with the right number of decimal places anyway. Let me try that again just to be sure. Yep, 30.5. 1 decimal place, that's what we need. All right, well, sorry, oh no, sorry, I didn't choose 18. 20 will be rank the following speeds in order of increasing magnitude. Okay, sounds easy enough, but we've got a bunch of different units. A is 0.25 meters per second. B is 0.75 kilometers per hour. C is, where are we here, number 20, 12 feet per second. And D is 16 centimeters per second. You might have some hope of comparing them to each other in the units that are given if each of them were the same number. Say if it were 1 meter per second versus 1 kilometer per hour, but it's not. And so what we're going to have to do is convert each of these quantities into the same units. And probably you could save yourself some work by choosing one of the units that's already given and convert them all into that. See, that way you don't have to convert that one. And I'm just going to choose the first one, meters per second. I'm going to convert everything into meters per second. So the first one is already done. The second one, 0.75 kilometers per hour. Let's see, we need kilometers to meters. And for that, we want kilometers on the bottom and meters on top. There are 1,000 meters for every 1 kilometer. Okay, so kilometers cancel. And now for the hours. We want seconds to hours. Hours is on the bottom of the fraction, so that has to go on top of the conversion factor. And we want seconds on the bottom, so that has to go on the bottom. There's 1 hour for every 3,600 seconds. Okay, so 0.75 times 1,000 divided by 3,600 gives us 0.208 meters per second for the second one. For the third one, the denominator is already in seconds, but we have to go from feet to meters. And so that means there should be a conversion factor on our sheet that will take you directly from feet to meters. And if I can find it, I will look it up. There it is. Let's see, feet to meters. There we go. 1 meter is 3.281 feet. That's all you have to do because the denominator is already in seconds. And so we don't have to do anything with that. 12 divided by 3.2881 is 3.66, I'll call it, feet per second. And 16 is centimeters per second. Oh, we lucked out. The denominator is already done on this one too. And we just have to go from centimeters to meters, and that's pretty easy. One centimeter is 0.01 meters, or you could also write it as 1 meter over 100 centimeters, either way. And so 16 times 0.01 is 0.16, or sorry, meters per second. So let's see, the smallest magnitude would be D. D is less than B is less than A, which is less than C. So that would be your order. Okay, so it was just a matter of converting the units to put them all on the same footing so you can compare them with each other. All right, that was, let's see, that was number 20. 22. So you got a car that's traveling at 68 miles per hour. And they want to know what that is in kilometers per hour. Okay, so we have 68 miles per hour. That's equivalent to being over 1. I seem to recall that our conversion sheet gives us a conversion for the speed between kilometers per hour and miles per hour. And there it is, first one. 1 kilometer per hour is 0.6214 miles per hour. Okay, so we want miles per hour on the bottom, kilometers per hour on top, and it's 1 kilometer per hour is equal to 0.6214. Okay, 0.6214 miles per hour is what's on the bottom there. And let's see, 68 divided by 0.6214 gives us 109 point something. And for the, because this is only 2 significant figures, that we really should round that off to 110 with no decimal point, because that's 2 significant figures. So it's 110 kilometers per hour. Sounds a lot faster that way. Okay, number 26 is, I think, the next one that's useful. It's about a diamond, the Star of Africa, and it has a mass of 530.2 carats, where 1 carat is 0.20 grams. And they want to know, what is the weight of the diamond in pounds? Well, that's given to us in carats, and they give us the conversion between carats and grams. So that's kind of a hint that the first thing you want to do is go from carats to grams. So 530.2 carats, and there's 0.20 grams for every carat. Okay, so 530.2 times 0.2 is 106.04 grams. That's too many significant figures, but this is an intermediate answer, so that's okay. Now that we're in grams, we can go to pounds. In our trusty conversion factor sheet, we have mass conversions. 1 pound is 453.6 grams. Okay, so that number divided by 453.6 is 0.234 Oops, we've only got two significant figures there. So I guess 0.23 is about as far as we can go on that. That would be 0.23 pounds. You didn't have to do it in two steps like that. You could easily have taken this conversion factor and added it on after the first one and just kept right on going. But I just kind of wanted to show you, okay, now we're grams, so then we can go to pounds. So not too bad for a question that sounded pretty daunting to begin with. Okay, for number 28, it says many highways have a speed limit of 55 miles per hour. And what they want to do, well, is find it in kilometers per hour. Actually, we just did a question like this up above here. So we can just take 55 miles per hour and the fact that there's 1 kilometer per hour for every 0.6214 miles per hour. And 55 divided by 0.6214 is 88.5. Oh, I guess it should be only two significant figures. So 88.5 would be 89 kilometers per hour. Okay, so not too bad there either. Number 30 is involves a fictitious unit called the jiffy. And the jiffy is supposed to be the time it takes light to travel 1 centimeter. And speed of light is 2.9979 times 10 to the 8th meters per second. And so the question is, how many seconds are in a jiffy? Okay, so basically what we want to know how many seconds it takes for light to travel 1 centimeter. And that distance, we have the speed of light in meters per second. So what we need to do is get those units to be the same. Either we have to change the distance we're measuring to meters or change the speed of light to centimeters per second. I think changing the one-dimensional distance would probably be the easier way to go. Okay, 1. And so 1 centimeter is equal to 0.01 meters or 1/100th of a meter. And so now if we have 0.01 meters and the speed of light means that light travels 2.9979 times 10 to the 8th meters for every second. But what this also means is that it takes 1 second for light to travel 2.9979 times 10 to the 8th meters. You can use that number upside down. And that's what I'm going to do. 1 second for every 2.9979 times 10 to the 8th meters. This is how far you have to go. This is how long it takes you to go each meter. Meters will cancel and you get seconds. So it's 0.01 divided by, and be sure that when you enter the speed of light, you use parentheses because there is some multiplication going on in there. 2.9979 times 10 to the 8th, close parentheses, and then hit equals. And we get 3 point, let's check for signal. Oh. Let's see, we got 1, 2, 3, 4, 5 significant figures there. When he says 1 centimeter, I'm going to assume that that is an exact number. He meant exactly 1.0000, on to infinity seconds, or centimeters rather. So that means this is an exact number. And so I guess that means, and that means also that if 1 centimeter is exact, that means 0.01 centimeters is exact. So I guess we get to use 5 significant figures. 3.3357. Whoops, times 10 to the minus 11 seconds. So there you go, that's a jiffy. How many jiffies are in 1 minute? And so let's see, this is 3.3357 times 10 to the minus 11 seconds per jiffy. And so a minute is 60 seconds. If you take 60 seconds times the fact that there's 1 jiffy for every 3.3357 times 10 to the minus 11 seconds, you should get the number of jiffies in a minute. 60 divided by parentheses 3.3357 times 10 to the minus 11, close parentheses, equals 1.79. 60 seconds per minute is an exact number, so that's infinite and significant figures. So I guess we get to use 5 significant figures again. 1.7987. And that would be 1.7987 times 10 to the 12th jiffies per second. All right, moving on. That was number 30. We can look next at 34. Although we're at 30 minutes now, so I'm going to end this segment and we'll go into number 34 in the next one.